take a look. About ionization, we have acids, okay? We have the ionization of acids and we have the ionization of bases. So in this moment, we're going to focus on the acids that are in the whiteboard, okay? I'm going to try to do them larger, the two of them. So take a look at the establishment of the rule. It says, when you combine an acid with water, you will get as a result hydronium ion and an anion. Okay? Remember, hydronium ion is H3O plus. So let's work on that. It says to ionize acids, we need to combine it with water. So that is the first step that we need to do. We need to combine the acid with water. That's what I'm going to do right now. So I will combine with water. For H2O. Okay? As a result, I will get hydronium ion. Hydronium ion, remember, is H3O. Is H3O, not H2O plus. No, it's H3O. You need to be careful with the substrates and with the charges. And the charge of the hydronium ion is +1, okay, or just plus. And then it says plus an anion. Now, how is this anion going to look like? Take a look. Hydronium it has a formula like water, okay? But it's water plus one more hydrogen. That's what it means, okay, the hydronium. Now, because here you add one hydrogen means that in the acid, you're going to take one hydrogen away because that hydrogen is going to go to the water. So because you're losing a hydrogen, you're going to get the anion. The anion is going to be the same acid but without one hydrogen. So it's going to be, the anion is going to be H instead of 2, it's going to be 1 or invisible 1, CO3, HCO3. That will be the anion. And because it is an anion, we need to indicate the charge. Because it lost one hydrogen, the charge will be negative. And that is the ionization of an acid. Let's try one more time, but this time try to participate in the procedure. What will be the ionization of sulfurous acid? What is the first thing that I have to do? I need to combine it with what?
Water.
Plus water. Now, this addition or this mixture is going to produce always hydronium ion, okay? And hydronium ion has a charge plus. Now, what is the other product that I could get? What is the other product that I'm gonna get?
HSO3.
HSO3. And the charge is
Negative.
negative. That is correct. So as you can see, these kind of exercises are quite easy because all you do is organizing like a chemical equation. Now sometimes I'm gonna give you this addition like that or just the acid. But right in the moment I say ionization, you know that it involves water, okay? Ionization involves water. Now, you can also do the ionization of bases. I'm gonna move this up.
Miss,
Yes,
I was going to tell you if you can make an example, but with the name of the acid.
with the name of the acid. Okay.
Yeah.
When I include the name of the acid, I expect that you know about naming. Okay. So in this moment, I will like also give you a review on how to name acids. Okay. Because that is what I consider it's the most important step. Okay. Now, I can ask you a word problem like write the ionization equation for let's see what acid I can include. Phosphoric acid. Okay. First of all, you have to be careful with the name. Phosphoric acid. What is the formula for phosphoric acid? And then you have to work. Remember the mnemonics that I gave you? You have to work with the mnemonics, but backwards. Let me see if I have the mnemonics here. Oh, yes, it is here. Okay. So this is the mnemonics that I gave you the other day. No lo sé, Rick. Okay, I think it's better now. Okay, so what happens here? How can you work with the mnemonics if I give you the name of the acid? You have to work backwards, okay? That's the key for this kind of problems. So take a look. Phosphoric acid. You cannot use the first mnemonics because the first mnemonics involves the prefix hydro. There you don't have hydro, it just says phosphoric acid. So this means you cannot use the first mnemonics. Now the second mnemonics says that I ate something icky. So ick, because phosphoric ends with ick and it doesn't have a prefix, you could use this one, okay? Phosphoric acid with the mnemonics I ate something icky. So because it ends in ic, because it ends in ick, you're gonna use The mnemonics, icky. Icky says that you ate something, okay? That you ate something icky. In other words, it means that the ion that you will use for this acid, the polyatomic ion, is going to end in ATE. So it's not going to be phosphoric, it's going to be
Phosphate.
You're going to take the IC away and you're going to write the ATE, sorry. But as you know, phosphorate does not exist because phosphorus is an exception in the case of the special roots for acids. If you want me to give you the special roots for acids, I'm going to give them to you. But I don't have it here. Special roots for acids. Oh, but if I'm not mistaken, I have two special roots. I have, sorry. For phosphorus, the special root is phosp. That's the special root. And for sulfur, the special root is sulf. For sulfur is sulfur. Okay? It's not going to be sulfic acid, it's going to be sulfuric acid. It's not going to be sulfose acid, it's going to be sulfurous acid. Okay? So these are the special roots. Remember this. So it's not phosphorate, it's phos, the root, and the ending ATE. Phosphate. The iron phosphate has this formula, PO4, and the charge is 3 minus. So we're talking about an acid that has the iron phosphate, and because it is an acid, you're just going to write the hydrogen and the plus ion above. Remember to interchange the position of the charge. So in the end, the formula for phosphoric acid is just going to be H, the 3 that is coming from phosphate, and phosphate, like that. So all this process just to say that this is phosphoric acid, okay? Once you have the phosphoric acid already with you do the ionization of it. So you say H3PO4, because it is ionization, you will combine it with water. As a result, you're going to get mandatorily hydronium ion, which is H3O plus, and the other product is going to be what? What is going to be the other product? It's going to be the same acid with one hydrogen less. So it's not going to be H3PO4, it's going to be H2PO4, and then with a charge of -1, like that. And that will be the ionization for phosphoric acid. Now, if you want to review naming, you know I have videos in my YouTube channel that is specifically about acids, so you can watch them. I can also send you the video of Tyler DeWitt when he explains acids. In my opinion, he does it amazingly well. So I can send them to you for you to review the topic about naming acids. And that will be it. That will be all the process. Just put in one hydrogen in the water, and then it acquires a charge of positive 1, and then the acid with one less hydrogen, making it an ion with a charge of negative 1. That's important that you include the signs, because that indicates that it is an ion. Now, we can also do ionization of bases. The idea is the same. We're going to combine it with water. But in the case of bases, we're going to have a different product. We are always going to have hydroxide ion, and the other part will be a hydride ion, metal hydride ion. Okay? So let's take a look at how to work with this. How I recognize a base in the first place. All bases have OH. Okay? So that is the first step. That's how I recognize a base, because it has the OH ion. Like that. Okay? So, ionization of a base is combining with water, and as a result, I will get hydroxide ion, which is mandatorily written as OH. The charge of the hydroxide ion is -1, or just the negative. And then it says plus metal hydride. What is the metal in this base? What is the metal? Is it silver, or is it the hydroxide ion? What is the metal?
Silver.
The silver. Okay, so this is the metal. And because it says metal hydride, hydride is the ion hydrogen, but with a charge of -1. That's what hydride means. Okay, so the product will be hydroxide ion and metal hydride, being the metal in silver, Ag, and then the hydride ion, that is H minus. Remember that silver has a charge of +1, and then positive and negative are going to be cancelled, so we don't need to write subscripts. Now, do we need to check if it's balanced? What do you think? Is it balanced? Guys?
No.
It's not balanced. Okay? So we need to do a balance procedure. Here you have, let's see. Okay, in the left you have 1 silver, 1 plus 2 equals 3 hydrogens, and 1 plus 1 equals 2 oxygens. Okay, in the right, sorry, you have 1 silver, and you have 1 plus 1 equals 2 hydrogens, and you have only 1 oxygen. So it needs to be balanced. So to balance, I will just put 2 right here, and this is going to change my hydrogen. Now I have 2 plus 1 equals 3 hydrogens, And now I have 2 oxygens, and we can say that is balanced now. Let's do one more example. Barium hydroxide ionization. Ionization means that I will combine with water. So this is plus H2O. And as a product, I will always get OH minus and let's take a look. Metal hydride. What is the metal in this exercise? What is the metal in this exercise?
Barium.
Barium is the metal, okay? So the other compound is going to be made of barium. Barium has a charge of 2 plus, as you can see in the periodic table. And hydride is the ion H negative. So you are going to crisscross the charge. The 2 from barium comes to hydrogen. And as a result, this is barium hydride. Now, what else? What do you have to see? What do you have to see now? It must be balanced. So to balance it, again we list the elements, barium, hydrogen, oxygen, and we compare the two sides. In the left, I have 1 barium, I have 2 plus 2 equals 4 hydrogens, and I have 2 plus 1 equals 3 oxygen. In the right, I have 1 barium, I have 1 plus 2 hydrogens equals 3, and oxygen, I just have 1 oxygen. So I need my exercise to be balanced. So how can I do to balance it? First, I will try to balance my hydrogen. So I'm going to put a 2 right here. Okay? My hydrogen is going to be now balanced, 2 plus 2, which is 4. But my oxygen, as you can see, still not balanced. Okay? Still not balanced. So to balance it, I need to continue trying with different numbers. So 2 didn't work for me. I'm going to try with 3. Now, why I don't change the other coefficient? If I change the other coefficient, I must change the coefficient in front of barium in the other side, so it makes it a lot more difficult. So that's why I work only with this ion first, okay? Right now, putting the 3 is gonna change it. Now I don't have 4 oxygens. Now I have 4 hydrogens. Sorry. Now I have 3 plus 2 equals 5 hydrogens. And oxygen, I have 3. So my oxygen is balanced, but my hydrogen is not. So I'm going to try with a different number. If 3 didn't work, I will try with 4. If I try with 4, this is going to affect my oxygen. I have 4 oxygens now, and also my hydrogen. I have 4 plus 2 equals 6 hydrogens. No, still not balanced. But what happens? I can get easily 4 and 6 in the other side by just changing another coefficient. take a look. If I put 2 right here, it's going to make my hydrogen to be 2 plus 4 equals 6. And also my oxygen is going to be changed. Instead of 3, I'm going to have now 2 plus 2, that it is equal 4. And that makes it balanced. In this kind of exercises, the balancing process is a lot more complex than the exercise itself. Okay, so I recommend to practice balancing this kind of exercises. Okay. Now, what is the difference between ionization and dissociation? In dissociation, what we have is any compound, could be ionic acid, a base, okay? It's going to split into its cation and anion. As an example, I will try first with an ionic compound. Let's say that I need to dissociate this ionic compound, okay? For example, let's work with calcium nitrate, for example. Calcium nitrate, it is written like that, okay? Now, what are the ions that are making up the calcium nitrate? Calcium nitrate is made of the cation, which is the one that has the positive charge. It's always the metal, okay? And the metal in this case is calcium. So the cation is going to be calcium. The charge of calcium is positive 2, okay? Now, wait. I'm gonna move this like here. Better. Now it looks better for me, okay? Now, it's the turn for us to use that anion. The anion is the polyatomic ion that is in the right side. In this case, we are talking about NO3. NO3 is the anion nitrate, okay? So you're going to split it. Now, the anion, remember, anions are the negative charge because they are like anions, and anions make us cry, okay? So this is the negative side of the ion, of the compound, sorry. So it's gonna be calcium, 2 plus, and the anion. The anion will be the entire parenthesis. Nitrate, which is NO3. And if you look for nitrate in the tables of polyatomic ions, nitrate has a charge of -1. Okay? Now, all you do is balancing the product. Okay? Here, you have just 1 calcium. So, in the product, you have 1 calcium. So, calcium is balanced. But nitrate, here, as you can see, you have nitrate that is being multiplied times the number 2, which is outside the parentheses. So what you do is you need to balance the nitrate, because nitrate is twice in the reactant for that same is going to be also twice in the product. And this is how you balance the dissociation process. And then if you compare calcium, nitrogen, and oxygen, you're going to have the same amount in both sides. 1 calcium in the right, 1 in the left, 1 inside the parentheses times 2 nitrogens, which make 2 nitrogens in the right, in the left, and also 2 times 1 in the right. And oxygen is going to be 3 inside the parentheses times 2 that is out. That makes 6 oxygen. And in the right side, also you have 2 times 3, that makes 6 oxygen. So this is the dissociation of any ionic compound. But as I told you, any compound could be done with this kind of exercises. So right now I'm going to try with the acid, okay? An acid. I'm going to try with an acid. Okay, HClO4. This acid is known as perchloric acid. So I have the ion perchlorate, okay? Remember, we work backwards from the name by using the second mnemonics. So we're talking about an acid that is made of always H plus ions and the polyatomic ion that in this case is perchlorate. Perchlorate is an ion that is written as Cl O4 and has a charge of -1. Now you have to look if it's balanced, and for what I can see, it's entirely balanced. I don't have to do the balancing process since it is already balanced. And you can also perform the same procedure in the case of a base, okay? For example, a base like aluminum hydroxide. I know it is a base because it has the hydroxide ion, okay? So that's why it makes it a base, okay? So the dissociation process of a base is going to be the hydroxide ion, okay? The hydroxide ion, which is OH minus, and you will combine it with the cation. Or you can put the cation first and the anion after. It doesn't matter really. It doesn't really matter here, okay? So you will have the hydroxide ion and the cation, which is the metal. The metal is aluminum, and aluminum has 3 as a charge. So the cation will be aluminum with a charge of 3 plus. You can arrange it as I said to have the aluminum first and then the hydroxide ion. And in the end, as I told you, you can combine it. You can write first the cation and then the anion, just like in the first example. Remember, the positive goes first and then the negative. You can arrange it also in this way, but just remember, you need to balance it. Since here we have the 3 that is multiplying the parentheses is the hydroxide ion. In the product, I also need a 3 that must multiply the hydroxide ion. And with this, you make sure that everything is going to be balanced. And if you don't believe me, you can try, okay? You can check the aluminums in the left and in the right. You have 1 in the left, 1 in the right. You have 3 times 1 hydrogen, that makes it 3. And in the product, you have 3 times 1, that is also 3. And in oxygen, also you have 3 outside the parentheses, 1 oxygen inside the parentheses, that makes 3 oxygen. And in the products, you also have 3 as a coefficient and 1 as an atom, subscript, that makes 3 oxygens. And with this, you make sure that your equation is balanced.